So if we use this new knowledge to find the vector form, then in fact we only need to calculate one starting point on the line. So for instance, let's take the easy one, x being 0 and y being 5. So we use that one as a starting point. And then for the direction vector, we just have to find a vector which is perpendicular to 3, 1. And hopefully you already see that to find a perpendicular vector, we just switch the two numbers. So 3, 1 becomes 1, 3. And then one of them changes from sign. So for instance, this one. Now let's check it again. So 3, 1 dot vector 1 minus 3 will give us 3 minus 3 equals 0. So indeed, this vector 1 minus 3 is perpendicular to the coefficient vector. So now I found in 30 seconds a vector form of a line given with the help of an equation. Okay, something similar applies if we look at a plane. So if we look at a plane, then we have three parameters, and then the first one before the x, the second one before the y, and the third one before the z will give us the coefficient vector 3, 4, minus 2. And then if we want to find a vector form, we have x, y, z being some starting point plus lambda times the direction vector plus mu times the direction vector. Okay, so if I know that the direction vectors are perpendicular to the coefficient vector, can you figure out some vector which is perpendicular to this one? And let's make life easy for us. And so apparently 3, 4 minus 2 dot product with some other vector, so let's call it ABC, should be 0. So 3 times A plus 4 times B minus 2C should be 0. Okay, and we can have a choice. We can choose whatever we like. So let's just say that this A1 here is 0. So first position I choose 0. Then for 4B minus 2C should become 0. Okay, let's pick something. And let's do it easy again. So if we would pick for C 4 and for B 2. Then I have 4 times 2 is 8, minus 2 times 4 is 8 again, is 0. So, and hopefully you recognize that what I've done is I've chosen one of the elements, in this case the first one as 0, and then used our trick from the previous slide. Switch the 4 and the minus 2 and change for one of the elements the signature. Okay, let's try that for the second one. And of course, the second one needs to be independent. So, important, we just choose a 0 on a different spot. So, for example, on the second one. So we choose y as 0. Then we'll just switch the two elements here. So, minus 2 gets on top and 3 goes below. And for one of them, we switch the sign. So 2, 0, 3 is perpendicular to 3, 4, minus 2. Well, let's first check this. I don't know whether you believe me. So let's just calculate the dot product of this new found vector. So let's erase this. Okay. So apparently 3, 4 minus 2 dot product 2, 0, 3 would be 0. Okay. So 3 times 2 is 6. 4 times 0 is 0. Minus 2 times 3 is 6. Okay, great. So now all the work is coming back to just finding one point on the plane, because we still need to have a starting point. Well, let's make life easy again. We choose x being 2, then we have 3 times x, 3 times 2 is already 6. For the other two, we choose zeros. We have a starting point, 2 direction vectors, and we have a very nice and elegant vector form of the plane. So, to summarize, if we have an equation in a two-dimensional space, then we have a coefficient vector built up with the parameter in front of the x and in front of the y. And this coefficient vector is perpendicular to the line. So this will be perpendicular to the direction vector of the line. The same applies to a 3D space. So if we have an equation in 3D, then the parameters a, b, and c form together the coefficient vector of the plane, which will be perpendicular to both direction vectors of the plane. Another word for perpendicular is normal. So a normal vector means it's a vector perpendicular to something. Okay, let's try to work this out. So we have a line with vector form xy being 1, 2 plus lambda times 3 minus 4. Okay, can we find a vector perpendicular to L? Well, of course, if we know that this is the vector form of a line, then this one here is the direction vector, 3 minus 4. And we know that the coefficient vector is perpendicular to the line. So the coefficient vector would be 4, 3. Remember the trick? Switch the two numbers and then change one of the signs. Okay, this one is perpendicular to the line. Find an equation of the line L. In fact, we have already done half the work, because this 4 should be in front of the x, the 3 should be in front of the y, so equation would be 4x plus 3y equals something. So the only thing we still need to find out is what is the value here. Okay, so we just fill in one point on the line. Do we know a point? Well, yes, of course. 1, 2 is on the line. So 4x plus 3y would be 4, plus 6 would be 10. So the complete equation would be 4x plus 3y equals 10. Okay, then the last question. Find an equation of a line M perpendicular to L. Okay, that looks very strange. So a line M perpendicular to L. If I know that this one is the vector form of L, then the coefficient vector of this thing is 4, 3. Okay, if we now think about an equation of a line perpendicular to L, then of course that would be something perpendicular to this one for the equation. So apparently the original direction vector, 3 minus 4, can be used as a coefficient vector of a line M. So the coefficient vector of a line M would be 3 minus 4. So the direction vector of the original line. Okay, so 3x minus 4y equals. And then we need to know a point, and they gave us one. 5, 2 is on the line. So equals 15 minus 8 equals 7. So the complete equation would be 3x minus 4y equals 7. Okay, again, similar exercise. So we have a plane, 2x plus 4y minus z equals 10. So what is the coefficient vector? It's just the numbers in front of the x, the y, and the z. So in this case, 2, 4, minus 1. Okay, then they want to give them a vector form of a line L, which is perpendicular to V. Okay, do we know something perpendicular to V? Yes, of course. The coefficient vector. That one is perpendicular to the plane. So line L would be x, y, z equals some starting point. Okay, 1, 2, 3, that's given, plus lambda times some direction vector. So in this case, we can just use the coefficient vector, because this one is perpendicular to the plane. Okay, then the last question, give an equation of a plane parallel to V through the point 1, 2, 3. So this is the equation of the plane V equals to 10. And I now need an equation of a plane parallel to V. So that means it has the same parameters in front of the x, y, and the z. And so everything which has 2, 4, minus 1 will be parallel. The only difference will be the resulting value. So now this should be 2 plus 4 times 2 is 8 minus 3. So that would give us 7. So the equation of the plane parallel to V would be 2x plus 4y minus z equals 7. So if we summarize this, then V is a plane given with an equation. The coefficient vectors are the elements in front of the x, y, and z. And this coefficient vector we know will be perpendicular to the plane V. Okay? How do we calculate a perpendicular vector? Then we know that the vectors are, the dot product of the vectors are 0. So in this case, if we have a coefficient vector and we have a direction vector, then CV dot product direction vector 1 would be 0, and also CV direction vector 2 will be 0. Please mind that the two direction vectors do not need to be perpendicular. Huh? They are allowed to be, but it's not essential. So this doesn't need to be 0. So these can just be a vector like this and a vector like that. And the only quality the direction vectors should have is that they are not in one straight line. So they don't have to be perpendicular. Okay, this is the end of our linear algebra part of week 5. Again, if you have any questions, please don't hesitate to contact me and will join me in the Teams meeting.